right, we'll go ahead and get started here. Welcome everybody to this week's partnership of week-long webinars with Midwest Cover Crop Council and Iowa Learning Farms. So we have a webinar every day this week over noon on a cover crop related topic. So hopefully you've tuned into this week's prior webinars and we'll catch tomorrow's last one Friday at noon. I'm Ethan Teese, the Conservation Field Specialist with Iowa State University and the Midwest Cover Crop Council. So I'll be moderating the webinar. And today's topic is equipment considerations for cover crops with Charles Ellis, Field Specialist in Agricultural Engineering with the University of Missouri Extension. And any questions you have can be entered into the chat and we'll address those at the end. So take it away, Charlie.
Thank you, Ethan. It's good to be here. I'm going to put something kind of in context of my talk today. I am located in East Central Missouri, about 30 miles north of I-70. So some of what I may be talking about may be more appropriate for my geographic area. So let's kind of keep that in mind since we are reaching such a wide audience that, you know, some things may be shifted a little bit due to climate changes. So with that, I'll get started, and I'm going to focus on equipment for seeding of cover crops. Really not going to go into how to plant into them with the following cash crop. This slide set's going to be based on how to get the cover crop seeded in different methods we may have there. So the first thing, I guess, maybe a lot of people might overlook on seeding methods. There's a lot of things that might factor into what method I'm looking at doing out there. And this is kind of a list that kind of made up myself on one day. You may think of some other things, but there's many factors that go into play on what we want that cover crop to do and what's going on before we plant it, like how quickly we need to get it to emerge, what's the existing cash crop, what's the weather conditions, the species growing season. I'm going to walk you through some of these and how they may affect your seeding method selection that works best for getting the results that you want. And, you know, they can be kind of complementary or even maybe competing needs that you're looking at. And kind of have to make a balance or decision based upon that. So when we look at putting cover crops in, I put this, graph up. I use this talk in Indiana. So this is Indiana crop progress from like 2023. And when we look at cover crop seeding windows or timing, that red line I put there about mid-September, a lot of times you'll see is kind of a threshold of when we need to get some crops seeded. And when we look at corn and soybean harvest there, kind of in the central, Midwest, I-70 North area. About that mid-September, corn and soybeans harvest has just barely begun. So this becomes kind of a first hurdle in getting the cover crop in and up and growing without impeding our cash crop. First, want to show you this. It's Midwest Cover Crop Council has a nice selector tool that can help us with that guidance. This is down each member state down to a county level. You can go in and put your cash crop in, some of the goals you want for the cover crop, and it'll pull up this grid here. And the gray area is the timing or when that cash crop you anticipate still being in the field. Green bars give you the suitable seeding window for that cover crop listed there on the left. And then yellow, we're getting kind of in the more marginal establishment window of that cover crop. This, I believe, is from a county that Indianapolis is in. So this is the example. You can go into your state and run some scenarios. So this kind of gives us the challenge we have of adapting the cover crop seeding window with the cash crop, getting the cover crop germinated, and at the same time not interfere with the cash crop, both by yield loss and harvestability of that cash crop. So I guess, one of the conditions on what seeding method we are using is what is our fall weather conditions in that area we're looking at. I think this, the graph I found this, the upper right was fall of 2024 in near Indianapolis, and they only had 5/100ths of an inch, I think, of rain in that month of September. So if you're looking at soil moisture for germination, that was definitely going to be a challenge, in the fall of 24. So if we're broadcasting a seed and we're dependent upon moisture to get germination, this will be a challenge in that conditions for sure. Species are going to have different germination temperatures. That's going to determine when I need to get that planted by. And then the fall growth link, what am I looking at? Am I looking at something that is going to winter kill? Am I needing some additional growth? And then the map on the left is, Indiana with their rough frost dates below 28 or below. This would also kind of determine our growing window for some of our frost-sensitive cover crops. Radish would tolerate that a little lower than that. Something like sun hemp, things like that would frost off. So we now need to look at that as our growing window for those crops. And another one is how quickly do I need to get that cover crop, out of the ground and growing? Got three examples here. The lower left, with the radish, that's kind of your, you see a lot of the very large radishes in publications, on their growth, and they can get there. It's just kind of the seeding window that is going to determine a lot of that. For my area, the first part of September is kind of, maybe the middle of September, you need to have that seeded to get that type of growth. Upper left, with Missouri, with number 3, I think, in the nation in beef cow herd, we're looking at a lot of growers are now looking at cover crops as not only a winter forage, but a spring baleage. So getting that up and out of the ground, like the picture on the right with the cattle that are grazing, a mix of a lot of different cover crop species there to get that much growth for them to graze. This picture is taken in first part of November. They're needing to get that seeded in a timely manner so they get that much growth for the biomass that's needed for the cattle. So let's just kind of look at another way to look at that urgency. Nathan Johanning and some coworkers in Illinois did some seeding timing and rates of cereal rye. And this really kind of shows, when we look at that, the green is the late September, early October. Orange is, mid, late October. And then the late is into November. So what we're kind of show here is the 30 pounds of cereal rye seeded in late September is going to have more biomass than the 120 pounds seeded, in mid to late October. So this is kind of showing you if you're needing that with cereal rye, that biomass, that just throwing, I guess, more seed at it as it gets later is not necessarily going to get you to what you're wanting. So the early seeding window, we've got seeding rates down to 30 pounds that are doing the biomass production of 60 pounds there in mid to late October. And then so you can kind of see after we get to 60 pounds and above, the biomass production of those seeding rates on the seeding window or dates doesn't change a whole lot. So, like I said earlier, just throwing more seed out there is really not changing that biomass production a whole lot. They also looked at some legumes, crimson clover, balanza clover. Take these the same dates that were seeded. The crimson, you can see, kind of hangs in there in that mid to late October, and then you get into November, and essentially nothing there. And balanza, Uh, it kind of follows that same pattern of early, get you a lot more biomass the following spring is when these were measured. And then, it tapers off, 50%. And then, even in November, it's dropped down to a similar number that crimson clover is at. Near where my office is, we have a Natural Resource Conservation Service Plant Material Center in Ellsbury. This would be, like I wanted to point out geographically, this was in a, about 30, 40 miles, north of I-70, along the Mississippi River in east central Missouri. And so they did some studies similar to what, Nathan and his colleagues had there in the earlier slide. So I want to kind of point out a few species here. Oilseed radish, as I pointed out, that early September window, you get that growth. And then as we get into October, like here, we're starting to drop off. And then, November, we basically didn't really have enough growth there before winter killed to really get a whole lot of biomass. And then also on the front side with our climate in Missouri, August heat and lack of rainfall, we can also go that other way and not get as much biomass. Some of the grasses and cereals they looked at in the ryegrass, followed that same, curve. In August, the temperature was, too high. We get into September, we're getting that maximum production, and then drops off in October, and then really kind of collapses there in November. And all these grasses here, you see the November timeframe, we've really lost pretty much all our biomass production. Cereal rye on this in this study was looking at it. It doesn't quite follow as much a decline as the Illinois data was showing, but same time we're still seeing that. Winter oats the same way. Maybe between the September and October, there's not a whole lot of change there, but also point out that we can also in our climate is put that cover crop out too early in August, where we get maybe some drought and heat stress on some of these cereals. The crimson clover and the vetch and winter pea, these legumes, these crimson clover and the vetch in this study looked like it tolerated maybe the earlier seeding, and then did well there, September and, October. And then again, on the previous species and slides, we get to November and our biomass production is really limited. Species growing season is also going to determine, kind of seeding method. The radish there, for wanting to get that much growth with radish, they have to go in, in that late August, early September timeframe that we would have, and get the large tuber growth and ground cover. The cereals here in the lower left. Again, the earlier frame as that data earlier showed would help, and then the crimson clover. There, get that established so we have some winter survivability. So the following spring we can get things up and growing. Seed size and rate's going to influence our seeding method. Kind of went to the two extremes here of turnips of 190,000 roughly seeds per pound, 2 to 5 pounds per acre. All the way down to a winter pea of, 1,800, size of a large soybean, and a seeding rate of 40 to 70 pounds. So when you're looking at that, two things to look at, we're looking at aerial application. 2 pounds of turnips per acre is going to be much easier to seed, and with that seed size, broadcast on the surface and get germination. Now, winter pea with its large size, it's not going to be practical to broadcast, especially out of a airplane or helicopter. And then also the likelihood of good germination by broadcast in that August, early September timeframe is going to be really iffy. And then cereal rye kind of there in the middle, where it's got some flexibility on that. Also want to point out maybe some things that are a little overlooked is what's the field conditions in the fall when we're seeding, and that really starts with the combine as far as getting some good harvest residue distribution across the field. That's going to greatly help or hinder, getting a cover crop and even the next year's cash crop, planted in a good manner. Some examples here. The upper right, that's a combine that's just 2 to 3 years old, and with the header widths getting wide, and some other options that the producer chose not to put on that combine, he's leaving a really wide strip there of a field that the residue is not getting to. So we're ending up with really variable planting conditions there, especially for broadcasting. The thicker mat there right behind the combine, the seed's really probably going to have to wait for some wind or rainfall to work its way to the soil, or if it germinates in that thatch, it may not even survive, and die, from lack of moisture. And then when we're seeding this, just like we would a spring cash crop, going through there, we have some variable soil moistures, cutting through the residue and the knot, things like that. The corn stalks there on the left are a lot tougher to cut through in the fall than they are the following spring after they've had a winter of decomposition. And then the root balls and stalks there, as the row units bouncing across that, can really get some variable seeding depths of your cover crop. And then the lower right is, I guess maybe what I've been thinking about is, are we starting to get on some of these fields that are getting had cover crops for multiple years now? This kind of residue buildup on the soil, that is a soybean stubble that with the beans were planted into standing rye. It was blooming, about 5 foot tall. So when you come back and harvest those beans, you've got the bean residue in addition to that high carbon straw that from the rye. So is that going to affect whether we can broadcast, or do we need to get a row unit of a drill or planter to get our cover crop into the ground? So some equipment availability is could also be an issue. My geographic area, we used to have a lot of wheat, and now that's diminished to basically corn, soybeans. So do I have equipment around to seed that cover crop? Do I go with a low cost spreader like in the upper right that's going to get across acreage pretty quickly, and cheaply, but at the expense of maybe needing a higher seeding rate or getting some variability in germination? The lower right, air drills are more pronounced now. Many more of those around that I'm already seeding soybeans and wheat with. Do I use that unit? Can get across those acres. That gets me good placement, but at the same time, I may be doubling the wear and tear on that equipment. That's going to be a cost of putting that cover crop in the ground, is the acres are going to be added to the drill and the tractor. And some producers, like in the lower left, that are committed to cover crops, have went out and bought a dedicated drill that they will use to follow behind the combine in the fall to get that cover crop in the ground and up and growing. So, availability, do I have it now? Am I ready to commit to purchasing equipment to do cover crops that I'd like? We've got livestock, which for Missouri is becoming more pronounced, or people are making use of. I need to look at getting it planted earlier, likely a higher rate of seeding of the species that I want to graze. We're likely using a multi-species cover crop to try to balance the ration that those cattle will be grazing. So then I've got to make that blend and what seeding equipment do I have that I'm going to be able to get that through and get planted appropriately. So when we're looking at that multi-species, like for cattle, we're going to have blends of seed of different seeding rates, different seed size, different seeding depth, flowability, are staying mixed, I guess, as it's going through the planting equipment. I need to kind of land on, I guess, maybe not the best for any of the cover crops, but seeding depth, but something that they can all tolerate. We've got, in this mix there in that picture, I know we had sunflowers all the way down to turnips, maybe some annual ryegrass, and some peas. So we're probably even looking at seeding depths there of, if we want to optimize each of the species from, 1.5 inches, maybe all the way down to, 1/4 inch. So just need to kind of land on an area that we can get everything out of the ground and growing. Labor, can be a issue. And again, the same equipment I had earlier, how quickly can I get that over the field? Can I combine it with a trip that's already going to be done in that field? So the labor and equipment's really not added on to what I need in the fall. The upper left with the spreader, that may be something that, when a child, a son or daughter gets home from school, can get in that and, in a short amount of time can catch up with what was harvested that day. Whereas the other two are going to be doing, I guess, a better job of getting the seed in the ground and up and growing, but would take a more of a labor commitment to get that done. Now we've kind of touched on what kind of determines our method we want to use. Let's kind of walk through some of the methods we have out there or being done. A little picture I have there is those are called horn seeders. When I was growing up, I have 3 older brothers, so there were 4 of us, and my dad bought us all a horn seeder. And this time of the year, the 4 of us would be out there frost seeding clover in our wheat. And I guess we were ahead of the curve on that. So now, that could be an early method of seeding a cover crop. And, we were, I guess we had a light footprint. We could get over a lot of different soil conditions. So I guess that would be kind of the most rudimentary method of seeding it. But that's looking back on that, that's what we were doing. So I'm going to walk through some of these others over here and see where they might fit in your operation or what you want to accomplish. Earlier, I'm going to walk through these, kind of progress through the growing season. Early interseeding. We've attempted this in our area a couple of times, and I'll share those results here in a second. This is kind of you're targeting prior to crop canopy. Done one of 2 ways. As the spreader, the John Deere spreader there on the left is top dressing the corn with some additional urea, nitrogen top dress. We've got seed mixed in. The lower picture is I believe Penn State's unit they have designed that can also, while additional fertilizer is being applied, they've got row units that can run between the rows and actually get the seed in the ground. Some things that herbicide sensitivity is going to be a big one here. Shade tolerance of the shade, and I would say for our area, drought tolerance, it's going to need to be a consideration of those cover crops you're selecting. The advantage of trying to get this done is getting it done this way, is labor savings. You're combining it with a trip, minimal crop damage. Getting that species up and growing, like I talked about earlier, for the growing window of the species may also be an advantage. So this was the first time, I worked with doing this back in 2016, and we attempted 6 different species here, and you look at the rates, and we really had them bumped up trying to help them out. And then you look at the herbicides we use, and it's pretty minimal. Glyphosate, atrazine, and we limited to that, and we did it in a conventional tilled field, and we got you see the soil moisture there, pretty some pretty good rains, and it came up, but by the time we did the harvest, corn harvest, we had lost all of our seeding. So from my standpoint along I-70, I'm not seeing this be successful. Maybe it may be a more of a northern climate might work better, but we also attempted this in another way of using clay-coated annual ryegrass in radish with the urea, and that did a really nice spread pattern with the seed and urea both, and spread well. And we got some germination there of, see the radish there in the soil crack, and then some annual ryegrass that came up. But again, the cover crop did not survive for that. So, like I said earlier, from my standpoint, for my area here, I'm not seeing a whole lot of any success, with this method. New Leader, which has a lot of their spreader boxes are on a lot of products like John Deere and Case spreaders. They do have a good database here, for spreading of cover crops. This is available online. They can spread cereal rye in that 70 to 80 foot swath width. Crimson clover being that smaller seed in that 35 to 45 area. Annual ryegrass, with the shape and form that seed is in, is going to be not as wide, that 40 to 45 foot spread width. And then the coated annual ryegrass, which is what we used on that previous demonstration, can get to that 80 to 90 foot spread width with that coating on it. And radish and wheat are also in that 70, 80. So they've got a pretty nice publication here of how to set that up, with the equipment, with your New Leader equipment that you might have. We move on later in the growing season. We call it late interseeding. This could be by ground or aerial. And some of the timings that for our area we've kind of landed on is, when sunlight is about 50% getting to the soil surface with corn, or if the leaves are dried up to the ear, might be the timing of doing that. Soybeans, when they're beginning to yellow, we want to get that seed to the soil and let the leaf drop happen after we seed, so we have a mulch on top of the seed, and not seed trying to get through all that leaf mulch to get to the soil to germinate. So some spreading distribution going through that crop canopy can be a hindrance. Can be a fast, it would be a fast, way of getting the seed out there. Effectiveness in corn and soybeans, from my standpoint, I see it work more consistently, I guess, going into standing corn than in soybeans. The corn right there on the right, radish, and I believe it's oats. Those are two cover crop species that we want to get out there in a timely manner, that earlier window, to get some good growth. And then the lower left of crimson clover, it's a good example of, another species you want to get established and growing, as that data showed earlier. Get a lot more biomass by getting that out there and growing earlier. We can, two methods, I guess, as far as ground rigs would be, broadcast, over the top, and we'd have some interception of seed by leaves and whirl, things like that. With this unit on the Heggie, we can put drops on that and just kind of blow it out underneath that crop canopy, and so we get a higher percentage of the seed, I guess, getting to the soil, and hopefully getting a better stand by by using that. So, late interseeding, as previous two slides were showing, it's going to be dependent on rainfall. My early slide of Indiana rainfall in September of 24, we likely wouldn't see, this in the picture, at harvest. So, put that out there with good intentions, but we probably wouldn't have seen that. So I'm going to provide that early window for seeding for some cover crops that are sensitive to the seeding window, needing to put out there earlier. And seeding rate, we'll probably, we probably want to look at some lower seeding rate species to help as far as getting over acreage, and not having to refill as often. And like, this picture, this provides a opportunity for some fall grazing with, the corn stalks combined with radish and oats, kind of that ration balance we're talking about with just cover crops can, provide some, livestock feeding, in the fall. Into soybeans, people may have concerns on, the picture on the left is about the timing of seeding. Some may have concerns on wheel traffic going through the field. I did a little, math demonstration there of, 10-inch wide tires, 75 foot, roughly, 2% of the field driven over. So, 50 bushel soybeans, I guess, we could say in a worst case scenario might be a bushel per acre, lost by driving over, assuming you're always running on a soybean plant, which you won't be doing. But, with the new technology of guidance systems, a lot of times we can run through previous used row tracks or tire tracks. So we're really not running over any additional plants by using, post-spray guidance and things like that. Also, pick a cover crop that's not going to interfere with harvest. The two there that, may be popular with going into soybeans prior to the falling corn, crimson clover, its early growth is pretty minimal. So cutter bar will, slide over that, and not be taking any of that into the combine. Annual ryegrass there on the left, is growing a little bit slow. You might get, a few clippings of, annual ryegrass into the combine, but, be minimal. I mean, take that into account that you don't want to add any, especially some green material to go in the combine during harvest. Aerial seeding, similar to the ground rig as far as, pointers. Airport proximity could be a limitation with an airplane. Maybe a helicopter, where it'd be more local, be next to it, would be another alternative. Species selection on seeding rate, is going to be a determinant on cost per acre, of the airplane, amount of time it's taken to get that seeded as far as refill times, things like that. So really looking at a lot of times with an airplane, the lower seeding rate, brassicas, turnips, things like that. Drones are starting, as they have in crop spraying or fungicide applications, are working their way into seeding cover crops. This one is probably getting a little dated. This is an early seeding with a drone. Some advantages of that are irregular shaped fields that plane or a helicopter would really not want to apply in with power lines or tree lines can reach. They might be able to respond to weather conditions that if we are looking at a wet period coming up suddenly in a day or two where we can get to the field and get that seeded. We can kind of customize species maybe to graze or even customize areas in the field that we want different species at, whether it be for erosion or grazing potential. Some data Dr. Kevin Bradley at University of Missouri has done on drone seeding of cover crops. This first graph, he's just kind of looking at what's really coming out of the drone. And the first one he as he explained it to me, he was looking at a mix, just a mix here that might be a cost share. So he's got wheat, crimson clover, and the green, which isn't on the legend for some reason, was hairy vetch. So when we look at that, you can see the pattern with the different seed size, different shape is different. It changes. Also, he was targeting 40 pounds per acre, which it's a high volume. Kind of looking at that, and then he just put in the book numbers, I guess, that the manufacturer is saying to get that rate, and he's falling way short of getting that seeding rate there. And then also the variability amongst the species was going to make it challenging. So then he was looking at single species with the drone. This was cereal rye, and he was looking at two different speeds of the spreading disc of 900 RPMs and 1300 RPMs to see what that would do. And I also want to point out, and he had a high seeding rate, again here, wind speed of 8 to 12 miles per hour, which and the travel speed of the drone of 16 miles per hour, and wind direction was from left to right, and he was flying 20 feet above the crop canopy. So you can see the effect that the wind speed has on on the spread coming from that drone at that height. You see, we were the wind would be blowing this way. We get out the 15 feet into the wind, pretty much drops off, and then on the other end, it's throwing it out. It's reaching out 30 to 40 feet out, and then as he sped up, the spinner, it really didn't make a whole lot of a lot of difference. It may have spread just a little bit further on that study. Then he looked at changing the height above the canopy. Again, this is the same conditions, wind left to right. This was at the lower spinner speed there. Again, into the wind, not getting much distribution out that way. Being higher up, is hanging up in the, taking longer for it to, reach the soil. It was getting, thrown out further, on that up, as the wind blew it further out there. So in those windy conditions, maybe, the lower, 20-foot height, was doing a bit better. Then on this, this would be crimson clover, different shaped seed, smaller, did some, the same things with this one. This one may even be more pronounced than the cereal rye. I mean, it just gets drifted out, out that way, as the wind is blowing that out. And when you look at the spinner speed, I'm not sure we can really say a whole lot of benefit by changing that. And then the height above the soil, again, the 30 feet, we were getting a lot of seed that was getting blown, if you want to call it blown off target or blown out of that swath with it, it's still in the field. So, we're not really getting much. And this is wind speed at 7 to 10 miles per hour. So we're really not looking at anything that would be out of the ordinary in our area that time of the year as far as wind speed. So if we're getting a lot of effect from that. And then at our one of our research farms, they were looking at the outlet size coming out of the hopper related to spinner disc. And not going to spend a whole lot of time on this. I mean, this is a publication that I'll have the address here, but just kind of showing that we really need to designate, devote some time to getting a good spread from these. This was a cereal rye, in the hopper outlet size at 30%. We got some pretty good stability depending on, spinner speed. These others, we're getting a lot of change there. And with the radish, something similar as outlet size of 50, 30, and 10%. As we change the spinner disc RPMs, we really start to affecting our seeding rate, with these cover crop species. Oats, this one, oats, we've really kind of walked through, three different seed types, I guess we'd say. The oats going to be that more fluffy, lighter seed. We got some, and, maybe flowability is going to be on less on that. So we've got to open that hopper outlet higher on oats than we did some of that, like the radish, to get some consistency of flow coming out of that hopper. So kind of the take home message, from that, was, try to get in that 90, 95% seed properties, density, application rate, and for calibration, only make, one change at a time, whether it be spreader speed or outlet coming out of the hopper. And, if you'd like this publication, this would be our Northern Missouri Research Center. And maybe Ethan, if you could put that possibly that website in chat or something, when someone wants to pull that out, feel free to download that publication. So seeding and harvest, is another becoming more prevalent, especially with Montag. They've developed the unit there on the left that goes on the combine. Some earlier adopters may have the seeding box on the head itself, the corn head or the bean head, and so when you changed from corn to soybeans, that had to be changed also, or you have two of them, and they also added additional weight to the feeder house, picking the head up, maybe block some visibility. And kind of the idea of this is to save labor and time by blowing the seed out underneath the head, prior to the combine spreading chaff over that seed. So it kind of does beneficial a couple ways. Getting the seed seeded, and then also getting that mulch to over the seed, and probably get better germination that way. It's going to slow some harvest down for refilling the seed boxes. And then, may want to, consider, lower seeding rate species if that's a problem. And then you also have to kind of coordinate, filling of the seeding with unloading of the combine. Just broadcast after harvest can be fast, higher seeding rate, with, increased seed cost, delayed germination, due to dry weather, like I was showing the graphic, Indiana or heavy residue like you may have here. Some ways to save on labor are and also equipment is adding to fertilizer. You just may have some variability in the spread pattern. Could possibly have some seed damage. Kind of a bullet point with just this type of method of seeding. The cereals. Generally don't work better, with this method. Maybe you can incorporate this into a tillage pass, adding the air box, right there, and just getting that seed to the soil, not adding labor, adding a little bit of equipment to seed, the seed box to it. Might start, depending on where that is hooked to the tillage implement. Seeding depth can have some variability there. Drill, it's going to be more time consuming than some of the others. Devote, a person or tractor to it. Planting conditions can be good or go to non-existent, where maybe a broadcast seeder, I could still get over some tacky or wetter soils. We can lower the seeding rate by getting that seed in the soil, faster emergence. And then, we can, when it's in the box like this, we can get some nice blending or mixing of a multi-species crop. Then, as I stated earlier, fall corn stalks can be a challenge to, cut through that residue. The root ball and the stalks themselves are going to affect, seeding depth, as those row units go through that. And one of the last ones is kind of come on the forefront, being used more often, is using a row unit planter, a split row planter. This is kind of a novel idea, and listened to Allison's talk a couple of days ago on proximity of cereal rye. This kind of falls into that of we can adapt the planter to different seeding rates, different seed size, individual row unit drives with electric drive planters. We can get some better seed placement, faster germination, cost reduction of the seed, get creative here. Like, we've got cereal rye in two of these pictures. Then we have a, clover growing between that. The upper right is, a cereal with a winter kill brassica. So, that could be the cover crop. And then, with the idea of controlled traffic guidance systems, come through and plant possibly a corn crop on top of that dead brassica row, the following spring. So, and then, or we could even choose to maybe in this left one, if we wanted to terminate the cereal rye early, terminate that with some herbicide products, and maybe leave the clover to grow longer. So it gives you kind of some, you got to have some pretty good technology to make this work, but it's out there, and it's on a lot of farms to be able to do. So I kind of tried, and with some colleagues' help, but tried to kind of condense that all into a table here of seeding methods, their costs, their placement, moisture, and integration. Hopefully this will be of use. We're still kind of Cover Crop Council in the process of getting this finalized, but kind of maybe a quick way to look at what I've went through here. I'm going to finish up here with just a couple of maybe related things. Herbicide effect on establishment. Dr. Kevin Bradley at University of Missouri has got a nice chart here on soybean herbicides in fall tree establishment. Anything in the green here is, he termed to be safe for these species of establishment that fall. Also depending on, rainfall and growing season weather. So he has, that, and then also a similar chart here of corn herbicides, with the same, green is considered, is safe, yellow, kind of a cautionary, and then the red can be, detriment to that cover crop getting established. Some people want to kind of play around with, maturity, groups, try to get that cover crop in. Just a little math. I did one day here of, kind of hypotheticals of, and for my part of Missouri, if I planted on the 18th, 114-day corn and 100-day corn, black layer, we had about a 12-day shift, maybe earlier. If we're looking at it, if we waited till May, that's, again, about that amount of shift. So, people want to look at that, or as service provider here tells me, maybe we need to encourage, harvesting at a higher moisture content, instead of giving up that yield, which is valid on going to a shorter season, corn. With soybeans, that'd be a little harder to do. We can't really push the harvest window for the soybeans. If you're looking at nitrogen credit from cover crops, this to maximize that, you really, as this producer nearby has, this is Harry Vetch, and his philosophy here is about Memorial Day is when he is planting that corn and try to maximize that benefit from the legumes. So if you're looking at legumes, need to have patience, which is very hard to do, when we're looking at that cramped planting window. Early seeding of this legume is beneficial to that, and really for maximizing that, wait for that blooming stage for termination. And with that, I'm going to end this. I just want to, point out, let's manage them carefully and not turn some good cover crop species into a potential weed. This is a wheat field from a few years back. I think we have, cereal rye and annual ryegrass of fertilizer carts that have not had the cereal rye cleaned out of them appropriately, and someone spreads fertilizer for a wheat crop, and then they start getting a little, cereal rye contamination. Just want to end with some resources. Again, point out the Midwest Cover Crop Council website selector tool, and we also have this nice pocket guide that you can get through Purdue Publications. Has a lot of information on the cover crop species that we have in the book, as far as planting window, germination temperatures, and where they fit in your system. So with that, Ethan, I am done, and I will turn this over to you. Thank you.
So we'll move on to questions here. The first one I had was from a farmer in South Central Wisconsin for you, Charlie. He said he interseeded rye aerially at the first yellow soybean leaves when he first started aerially seeding cover crops. And it definitely caused some harvest issues and staining of the soybean seeds, which he would not recommend. And he moved to timing back to 50% of leaf loss and has not had issues and still had good germination. So if you have any thoughts on that, or maybe some solutions for those harvest issues and staining of soybeans when that rye is taken off.
No, I appreciate that input. And, you know, geographically, he's got different conditions than what I could probably, I should probably address. But no, I think, like I said, the ones that we have used for Missouri conditions was the slower growing crimson clover, maybe annual ryegrass, you know, where that cereal rye and his conditions may have really had a healthy start, and that may have been a good condition. We've also had a couple of reports kind of off topic of growing green or planting green into green rye of some of that waiting so long that they've even got that cereal rye coming into the bean sample coming through the combine that fall too, kind of off topic. And you know, that may be an area, you know, in management that you want to consider also is you know, getting that terminated before it can make a viable seed. But I appreciate his comments, and I think they're right on.
All right, one more question we had here was, you mentioned long-term cover crops and no-till leading to heavy residue levels on the soil surface, and this leading to cash crop seeding complications. Do you have concerns about nutrient cycling from having a second crop, cover crop, pulling nutrients from rooting depth and depositing them on the soil surface, leading to accelerated stratification of soil nutrients?
Well, I'm not a soil fertility person, but I think sometimes in those types of questions, we look at soil fertility in too short of a time frame. If we're looking at a system approach over a 5 to 10 year period, you know, we'll constantly be getting some decomposition and those nutrients going back into the soil. And also, I think with root development of some fibrous roots, you know, as those roots, you know, die off and decompose, you're going to have fertility placed back into the soil where those roots were at, you know, things like that. I think the stratification, if you're really at a low, down to that threshold of where you might see a big yield response to an application of fertilizer, may be the case where that would be. But I like to try to think of, you know, over a 5 year period, you know, that plant's picking up something that was in a cover crop 4 years ago, 3 years ago, maybe picking up some from his manure from 20 years ago, I guess. So I try not to look at like that in a short window like that, and maybe someone on here could chime in, but that's kind of my approach to that, on that.
All right, I'm seeing some thumbs up coming through on that, so you must have some agreement there.
I like that.
That's all the questions I see for now. So thanks everyone who tuned in today.